that speed at which that light and that dark travels to my eye is so fast.
Except for Muhammad Ali. He said, I'm so fast, I could turn out the lights and be in bed before it's dark. I came of age. I'm a little older than you. I came of age.
You're a lot older than me.
When people... I have to adjust what he just told you here.
Like a chiropractor.
Oh, is that Lion King?
We get him.
It is almost never possible.
No.
Can I ask a question?
No. This is StarTalk. Neil deGrasse Tyson, your personal astrophysicist. And I got with me as co-host today, Paul Mecurio. Paul, welcome back.
Thanks for having me. Great to be back with you, buddy.
Yeah, this is the attorney, stockbroker turned comedian.
Yes, attorney, investment banker turned
There's
comedian.
nothing funny about
Yeah, exactly.
lawyers and stockbrokers.
No, exactly.
Okay.
I found a way to run from it as fast as I could.
All right. So, Paul, we're going to do grab bag cosmic queries.
We are. We got some great queries here.
And I don't trust myself in grab bag mode.
Yeah.
I need backup.
Yes, you do.
I got to go for the big guns.
You need your Starsky. Your Hutch.
Starsky and Scotch, yeah.
Wait, I'm
you have to be
Starsky,
70
you're
to get that reference.
He did pull up in a Ford Torino.
Charles Liu, welcome back to StarTalk.
Hi, Neil. It's great to be back.
Charles, longtime friend. Our families are friends and we're colleagues.
Yes.
You were here when we built the new Rose Center for Earth and Space 25 years ago.
Has it been that long?
It's been a quarter century.
Jeez, it feels like yesterday that I came over here and
know.
this place was a hole in the ground.
Yeah, it does feel that way.
Yeah.
And it was, you have intellectual and sweat equity in what we built here. So
it's wonderful.
We're thankful for that.
It was fun.
And
That's weird because when we were talking, he wasn't here. You said he didn't do much. You took a lot of the credit. I don't know.
Well, he's not wrong. I mean, I was just hanging out here all night having a great time. Yeah, that's all it was.
Just jump right in.
Okay. All right. Let's do it.
This is Galaxy. Hey, Dr. Tyson, Dr. Liu.
Galaxy's the person.
Yeah, Galaxy.
Galaxy, okay.
That's there. I am Brian from Roseville, California. I just recently joined the Patreon, and I'm excited to have my question answered.
Welcome.
Yes, thank you.
I gotta say it right. Welcome to the universe. Okay.
We dim the lights when you do that. Woo! I have always wondered how giant gas clouds and nebula exist in space. Shouldn't the vacuum cause all gas to disperse evenly to the point of not being even being able to see it?
I love that because on Earth, any cloud of gas disperses.
That's right.
As dogs know.
That's right.
Dogs will smell you from far away because whatever's your stank.
Yep.
1 minute in, and he says the guest has stank. This is a lesson, anybody watching, on how not to host a show.
At least it's not smell-o-vision.
Goodness
gracious.
Yeah. So it does dissipate.
It's a great question.
You look at blood in the water, and that
does it dissipate evenly?
It's a diffusion equation
right.
where you have molecules. It wouldn't happen in solid because all the molecules are just rigid, but in a fluid,
vibrate. They can vibrate.
No, but you're not going to move it through the system.
No, there's a phase issue.
I'm saying it's not going to move through the system.
Just trying to get technical.
Okay.
Yep.
And
wow, this is getting tense already.
Well, he called me skank. I mean, what am I supposed to do?
I didn't say skank.
You know
I said
what?
Stank.
Oh, stank.
We don't need this. We'll do our own show.
There we
Come
go.
on,
Okay,
let's
Paul,
go.
we out of here.
No. So the diffusion equation. So you have a molecule that can move like all the others, and it just works its way through.
Yeah.
In my high school, there was a diffusion experiment where there's a long tube. It was one of these display, because we didn't have any athletic trophies to put to a geeky high school. So you got to put other stuff in your hallway display cases.
It's a hall of beakers. Is that
Yeah, one of them is a very tall beaker. Yes, about this tall, if I remember correctly. I was littler, not much littler, but I think it was this big. And there was ink at the bottom.
Yes.
And they carefully put water on top of it.
Yep. Mm-hmm.
And throughout the year, you got to watch, because the ink is slightly denser, but still they're both fluids. And so you get to watch the ink work its way up real slowly.
Yeah. At my high school, they had diffusion experiments every afternoon after the school lunches were served bean soup.
Oh,
And in every classroom, there would be an experiment of
was-
different particles suspended in the atmosphere, moving from one side of the classroom to the other.
I got it.
After you first heard that something
and people
was
didn't
coming.
figure out to not eat the bean soup.
Right,
okay.
exactly. And that's where you got your name, Skank. Right?
Stank.
So did you? But could you do that same with the ink? Could you do it with oil, like cooking oil?
Yes.
Or olive
Well,
oil? Would it
it's
work?
harder. No, because oil would float, and the miscibility between oil and water is very different because ink is most inks that we use today are water based anyway. So the water is finding the water molecules.
Yeah. So Brian, the answer is basically the conditions out in space make it so that these gas particles tend to disperse unless they have a reason to collect. Okay, here on Earth, you have different kinds of things like buoyancy involved and things like that. That also happens in space. But in space, when the temperatures are very low, say 400 degrees below zero Fahrenheit, gravity can actually overcome a lot of the motional sort of dispersive, diffusive.
Emotional?
Emotional.
Okay.
Yes. It could be emotional. You know,
Clown said, I ain't doing this.
It's very moving.
yeah, that's right.
You tear up. You start crying a lot.
Emotional. I never
It's
heard
true.
that word.
About
Okay,
to become
emotional.
a star. Oh my gosh. Yeah.
Yeah, some gas
when it's
clouds become
cold,
stars, yeah.
Yeah, when it's cold, the random motions of the gases are actually overcome by the mutual gravity that they exert on each
But
other.
does it happen? Is it dispersing in an even nature?
Not at all.
evenly? No.
Everything is turbulent. If you go see, for example, beautiful pictures of, say, the Orion Nebula or other interstellar clouds, you see that they're streaky and strange and unusual shape. They look like horse heads. They look like helixes and cat's eyes and things like that. And that's completely because the turbulence is still going on.
Is it that,
but
or
just
because
on
you were smoking
gigantic
something
scales.
funny?
That
Is
too.
right?
You know?
Both worked.
We got to ask these stars that are emitting their planetary nebulae, what are they smoking? You know, I think that would be a very, very good idea. But the bottom line is that in space, you have gravity holding these clouds together long enough for them to do things like form stars and planets. But there's always these forces and these different energies and so forth for trying to disperse them. And so you get beautiful combinations, and that's why you get beautiful nebulae, and you get things like stars and planets.
I will add that you have a gas cloud that makes a family of stars. So that eats up most of the mass of the gas cloud. But there's part of the gas that didn't participate in the formation of the
little
planet.
snooty, like you were in high school. A little snooty, little standoffish. Nah, I don't
It
think
just wasn't there. It was, and that gas doesn't always land on a star.
Do we know why? In all seriousness.
Well, now the gas doesn't have enough gravity to make it a next star. We're done.
No, but at the time, and I'm not trying to be
Oh,
funny.
no, it's too far away. So watch
that
it.
gas,
I got this.
like all the other gases, had an equal opportunity
I
to be
got
part
you.
of that.
It's not an equal opportunity system. If you're a little too far away, you might not feel the strong enough gravity to participate, and the stars form without you. And then I like that hand gesture because I'll follow up on it. The whole galaxy is rotating. Okay, so your whole system with your stars and your gas is moving, and there's through other stuff. So your gas can get stripped and scatter into the galaxy, never to make another star.
So that gas just continues as gas throughout the universe.
And these are the particles that comprise the interstellar medium, even between the gas clouds. Yeah. It's not completely empty.
Okay.
Yeah.
And can that gas marry with other gases eventually
yes.
and sort of possibly be part of another?
It depends completely on like what Neil was saying. What is the rotational shear? What is the temperature in the environment? How much of it just happens to gather at this moment, whether it can actually collect or not collect? It's really beautiful and fascinating dynamic. But the funny thing is, it is very, very sparse, right? Here on Earth, we have trillions upon trillions of particles of gas, even in the tiniest, beaker or vial. But out in space, just even a couple 100 miles above Earth's surface, we're lucky if we even get one gas particle.
It'd be the best vacuum
that
ever
same
created
space.
on Earth.
Yeah.
Is what space.
So people who study interstellar clouds are literally studying nothing.
Yeah.
And yet that's the nothing from which we come from.
Right. So it's endlessly fascinating.
Yeah.
Such is the layout of this cosmic ballet,
Well said.
choreographed by the forces of gravity.
It's more like a Martha Graham kind of ballet makes it too orderly.
I don't know. I'm feeling Alvin Ailey.
Okay.
A little Alvin Ailey going on.
Yeah, we go Alvin Ailey.
All right, okay.
Alvin Ailey
I've been buked.
wins every time.
All right, we're moving on. Great question, great answers. Christopher Wynn. Hello, Dr. Tyson, Dr. Liu. I am Chris Wynn from Ottawa, Ontario, Canada. I'm new to preaching and love the show. My question is, during the Big Bang, what went bang? If we don't know, what are your best guesses?
There's only one answer here. It's the universe went bang.
Right.
Okay, next question.
I could take
Well, we know the idea.
I got that one.
We know the idea of personal space was blown to bits, right?
Look, the term Big Bang was actually coined by or
But
attributed
it's so
to.
misleading because it's
Right.
about expansion,
That's
not
right.
about bang.
It's attributed
and why don't
to-
you guys fix that?
I've tried. I've
we,
tried.
we there's a lot of legacy language
Yeah.
that permeates our field, and it's makes it historically interesting.
Can I ask a question?
No.
This is,
So
in all seriousness, how would that process work within the scientific community if you wanted to sort of take on the task of changing
We
the
have- we have
terminology?
a
Oh, you mean
mechanism for
like
that.
if you change
Pluto, don't
the
even say.
status
Stop it!
of-
Stop it! I'll kick you out of this office and throw you off the
No,
roof.
say it. I
Well,
want
I'm already stank, so I mean, why not, right?
Come on, Stank.
No, no.
Wait. No.
Go ahead,
Two,
go ahead.
two very important points here.
Yeah,
So
yeah.
finish your Big Bang story.
Yeah.
Okay. The Big Bang term is attributed to a guy named Fred Hoyle. It was an interview done early on in the middle of the 20th century. And
Back when ideas for the beginning of the universe were still uncertain.
Right.
And they were still contesting.
Right. And so he
Hypotheses.
himself did not like the idea that the universe started from nothing or something very small and became something big. And so the journalist that he was speaking with or interviewer or whatever said something like, so you're thinking the universe is kind of like a big bang of some kind. And that just stuck.
Did he do it to make science, in all seriousness, sexy? Like sort of to get people to sort
Today,
of more
no one
excited?
really knows. I've seen it historically expressed as it was derisive or that it was spectacular, one or the other. But yes, the right answer is it's an expansion of space and time from something small to something big. It was not an explosion.
Right.
And now we have this problem where we think, oh, if the Big Bang is an explosion, what did it explode into? You know, things like
Well, a
that.
key part of that
Right.
is
Where did it explode from?
yeah.
There's a lot of other.
and then there's this thing called cosmic inflation,
That's right.
Which which happened in the first tiny fraction of a second,
Which
of
is
this-
an expansion within an expansion.
Right.
You know, imagine if you're blowing up a balloon slowly and then suddenly someone slaps you on the back and your air all goes out at once, you know,
Right.
and it blows up. And we call that inflation, which gets mixed in with all
named
kinds of other
during
things.
the Jimmy Carter era hyperinflation that was
Just before.
existed at the
Just before. Nixonian times.
Are you sure?
But there is a
I'm
theory.
pretty sure. But it was like 10%.
It was in the 70s.
But there
Yeah,
is
it was
but
10% inflation.
When
Yeah.
this happened, okay,
Yeah.
this cosmic inflation, there is a theory that a gas cloud formed the initials WIN, which is whip inflation now. Jimmy Carter. Come on, that was good. That was
Yeah,
good.
okay.
See how I brought that back?
Okay.
Come on.
It's historical, though,
Yeah.
right?
Oh, by the way,
everything
just
is
a
historical.
quick, just while we're on the,
Sure.
how does it relate back to
Yeah.
society? I came of age. I'm a little older than you. I came of age.
You're a lot older than me.
When people,
I think I heard him whisper, "Your oldest dirt," and I didn't think it was a very scientific term, but that's what he used.
I think I'm 20% older than Charles here, plus or minus. So I came of age when we applied computing power
Yes.
to what galaxies would do to each other when they encountered.
Classic paper by two brothers, Alar and Yuri Tumre in 1972.
Tumray and Tumray. Yes.
Terrific paper.
Yeah.
What kind of data are you inputting into the computer?
We saw these weird looking galaxies out there. This is just an analog, so I don't want to spend too much time on it. Really weird looking galaxies. And there was someone in our field who compiled them into one catalog
Chip ARP.
called the Atlas of.
Peculiar galaxies.
Yeah, these are galaxies are just weird. They don't match any form.
Right.
So I don't know why, but here they are. And everyone's saying, what could make these galaxies? Are they born that way? And then Gerard de Vaucouleurs, who was a galaxy
Jerry.
guy.
I call him Jerry.
Yeah.
We're like this.
he was very French. He
Very.
was pretty sure that a crashed Lexus is not a different kind of car. It's still a Lexus. Okay. So that was
It
his
becomes a
analog.
Toyota, actually.
So he
Sorry,
becomes a Toyota. Good one. Good one. So the idea that, no, they're not peculiar. They changed because they had these encounters. these collisions.
These galaxies collide.
Yes, and they're colliding all the time.
Right.
Okay. Now, I forgot why I was even going to mention
Cosmic
this.
inflation.
Where was I going to non-inflation? Oh, yeah.
Chip
So
arc.
at the time, this is now in the 80s, okay? These are your people now. In the 80s, we called this.
Wait a minute.
No, you'll understand why in 10 seconds.
Come on, Eileen.
So we called it in our field mergers and acquisitions.
Oh my God.
We did.
Are you serious?
Yes.
I had no idea.
Galaxy mergers and acquisitions.
Oh my God.
So we
Because
got
that was
that term.
so hot then.
It was so hot right out of
Yeah.
Wall Street. So we have inflation and mergers and acquisitions.
And now look where we are.
That's right.
We're with Dr. Stank. And,
Hey, StarTalk fans. I don't know if you know this, but the audio version of the podcast actually posts a week in advance of the video version. And you can get that in Spotify and Apple Podcast and most other podcast outlets that are out there. Multiple ways to ingest all that is cosmic on StarTalk.
the Big Bang within the Big Bang at the tiny fraction of that moment when it happened.
Yep.
Is there still yet an explanation as to why that had happened?
There are numerous competing hypotheses, but we don't have the experimental evidence to show the initial burst or the thing that caused it to happen. We're pretty sure it did happen.
And
There's
we got
lots
close
of
to that
information.
energy. The bigger part is our particle accelerator. The earlier in time it can see, not see, but represent
Right.
in the temperature density in the particle accelerator. You can say in the first microsecond or the first nanosecond of the universe, what was the temperature? Oh my gosh, it was this high. Have we ever reached that temperature in the lab? No, not yet. The day we do, we get to say, we think we have sampled what the early universe would have looked like. Do new particles pop in? Is there a dark matter particle that shows up? We don't know.
But do you both understand as brilliant scientists that lay people like myself are looking for, in all seriousness, solid answers, right?
Yes.
Like I'm still trying to figure myself out.
Yes.
Hang on a second. Trying to figure myself out through counseling, therapy, whatever. The universe hasn't been able to figure itself out in 13.8 billion years. Can you guys get on the stick and give us an answer?
I would like to, but this is you hit the key point in the difference between, you've hit the key point between what I think is the difference between scientific truth and non-scientific truth. With scientific truth, we always put in the, but maybe we're wrong part, that we don't know for absolute sure part. And that's really, really important, right? Science could not have progressed if somebody said, this is the right answer. And then everyone just, okay.
People would have stopped
because it would have stopped.
exploring.
Right. It's incredibly important to recognize that we have ignorance. Neil has a terrific term for this, the perimeter of ignorance. We have to understand that there's a space beyond which we don't know the answer yet, or even what we think we know could be wrong because of this, and this.
Which is why, Paul, you need to love the questions themselves.
Oh.
In your search for answers.
That is too profound.
Dude.
Too profound.
No, that's Rainer Maria Rilke in a poem. Yes. Plus, I have to adjust what he just told you here. Okay.
Like a chiropractor.
He's gonna
adjust. Wrong word. I need a different word.
He's gonna straighten your mental back out.
Your mental vertebrae. Yeah. So I put a lot of thought and energy into defining what true means, and I've settled in a way that I think is highly defensible and should be adopted. Okay. So a scientific truth is that which has been established by repeated observations and measurements. When that happens, it is not later shown to be false. So we can talk about it as an objective truth. E equals mc squared is not one day going to be found to be false. That Earth goes around the sun, that the sun is hot, that the sun undergoes thermonuclear fusion is not going to one day be found to be false. Where Charles is referring to, we have to have some acceptance that we could be wrong. Yes.
About things that we are not definitively
correct. On the frontier, we're wrong most of the time.
Right. But there are some
90%.
There are some things that we've reached.
At least.
The community is comfortable saying, you're saying that there are some things, E equals mc squared, et cetera, where we're not questioning that anymore.
The huge things huge swaths.
Otherwise, you can't do.
Otherwise, we're not flying airplanes.
Otherwise, you can't do the exploration into the things that you don't know.
Airplanes wouldn't fly.
Right.
Rockets don't go to Mars and land exactly where we tell them.
You could continue to research that there's another rationale, but I think what you're saying is...
No, hold on. Let me finish. I'm almost done. Okay. It doesn't mean that we will not one day find a deeper truth in which the experimentally verified truths are embedded. Such was the case with Newton's laws of gravity and motion. Those laws in the realms in which they were tested are still valid. We went to the moon using Newton's laws and not Einstein, okay? There was no relativity in the Apollo voyages. It was all Newton's laws of gravity and motion. We then learned that at high speeds, high gravity, Newton's laws break down. Holy shit. Do we discard Newton? What's going on?
Well, there's gravitational waves.
So Einstein finds a deeper understanding of gravity and motion. And he gets his theories of relativity, the special theory and general relativity. Guess what? When you plug low speeds and low gravity into Einstein's equations, they become Newton's equations. People say, oh, we've Newton out, Einstein in. That misrepresents what's actually happening here.
Well, you can't have, it's chicken and egg. You can't have one without the other.
Well, no, I mean, in terms of the pathways of discovery, you get the restricted case before you discover the general case.
Right.
My only point is the uncertainty that a scientist brings to the frontier is in the realm of things that we have not yet experimentally verified. And it's completely uncertain at that level. And we're just duking it out at conferences and the like. And the press eavesdrops on the conferences. They say, oh, the scientists don't know what they're talking about. And then people say, I don't trust science. Yeah. As they're on their smartphone talking to someone 1,000 miles away. I don't trust science, you know? So I just want to clarify that. And two other truths. There's your personal truth. Like, is Jesus your savior? Is Muhammad your last prophet? Is Beyonce your queen rather than Taylor Swift. Right. So that's a personal truth. Then you have political truths, which are things that become true in your head simply because they were repeated so often.
Yes.
Which are the foundations of...
Or because you read it on Twitter.
No, it's how many times you read it. It's not. It's how many times. And so...
Is that any different?
Those are the foundations of propaganda.
But is that any different than commercial advertising?
No, exactly the same thing.
You're going to show you this Toyota 50 times, and by the end of the week, you're going to be like, I got to get a Toyota. That's a great car.
And no matter what they're telling you, that becomes true.
Right.
So those are the three truths.
Right.
And I will never speak of an absolute truth because that's not what science does.
Newton's gravity was proven to be wrong is true. It was wrong because in certain conditions in the universe, it was not correct.
But that's an
that didn't
eye-opening
mean.
moment.
But those are extreme conditions well beyond the experimental realm.
But that expands our...
Yes.
It's a good thing.
Yes.
When a bad thing happened like that, it's a good thing because it expands our base of knowledge.
And we don't call it bad.
Doesn't mean,
we don't invest emotions in it. Some people do, but it's not good if you do.
Yeah.
Right.
Well, I talk like a 6-year-old.
No, so do I.
Well, this is
way
perfect because this next question is about gravitational waves.
Love it.
I'm telling you, this is eerie. That's okay. This is Mitchell Ransom. Mitch from the UK. I would love to know more about what we can learn from gravitational waves. It's cool we can detect them, but what can that do for our understanding of the universe?
Marvelous question.
Perfect segue.
Marvelous question.
You take this out, back cleanup on it. Okay, go.
I will be the one Soto to your Otani.
And then I'll be the guy who shouldn't steal second and does and gets thrown out and ruins the inning.
Well, if Otani were stealing, he'd actually make it.
Oh, my God, yeah.
Or if you're going to steal second, do it deep into the count of a batter you want to see come up again in the next inning.
Also, that's true.
Right, because they get fresh.
Right. And
this
also
is fundamental baseball, which doesn't get talked about nearly as much as it should.
We should do a whole thing on baseball.
Oh my God! Yeah.
Oh my gosh!
We could all geek out. I think the pitch clock, while it's helped speed the game up, I mean, stealing is so much more interesting and fun to watch because you go over there twice, you know you're going to get you can't go back a third time.
That's right. So they're very interesting. Rules are always fun too. Talking about rules.
It's the most interesting sport to watch, I think, baseball because of all of the machinations. But anyway.
Yeah. Okay. Well, here's the deal. Gravitational waves are essentially to the universe and space and time as, say, ripples are in a pond, right? So if you see ripples going on in a pond or any body of water, you can deduce things about that pond. What is the water made out of? Is there duckweed on the top? How deep is it? Is there ice? Things like that. All the different things about that puddle.
By the way, the depth affects the amplitude of the ripple.
Completely, right.
So it's why when you're at the beach, how come, you see a swell sort of out there, but then it gets closer to the shore, it becomes a big wave. Yeah. So the energy that is out there in the ocean, which is shared vertically to the bottom of the thing, as you get shallower and shallower, that energy has to manifest somehow, and the height of the wave grows. And so the energy is the same, but the height and how you experience it as a beachgoer.
But where does wind come into this? Because wind can create a
wind
ripple,
can
right?
also
It doesn't
create a
have to
ripple.
just come
That's
from...
right. The top has an effect, the bottom has an effect, and the side has an effect, right? Where is it coming from?
In other words, it's bouncing off the
right.
the sides of
The edges
lake
make
or-
a difference if you're in a bay or if you're just hitting a
lake.
wide shoreline. Also, what is the material of the beach? Is it rocky? Is it sandy? So gravitational waves literally have the opportunity, if we're sensitive enough to detect them, to tell us about space-time, the structure of the universe, the things that these ripples go through.
Got to add real quick. Charles is talking about things you would know beyond just the simple detection of the wave.
That's right.
It's one thing to know that there's a wave there. Now, what's the amplitude? What's the wavelength? How many of these are there? Are they coming from this direction? There's different layers, but the Nobel Prize went to basically the first time it was ever discovered. And then you can keep asking more detailed questions.
That's right.
When your telescopes become better to do so.
That's right.
But this
pick it
gets to Newton's law of universal gravitation, right?
Absolutely.
Which does not provide for the existence of
Correct.
gravitation waves. It asserts that gravity has instantaneous effect, which is wrong.
That's right.
Because I dropped a 1982 bottle of Chateau Lafite Rothschild, and it fell
seriously do that?
in slow motion.
Did you seriously do that?
It landed on a pillow, I'm sure.
And it fell in slow motion.
Yes.
Everything slowed down.
Yes.
So Newton's wrong. I'm right. No, but that's where Newton and Einstein, right, are sort of.
Wait, just to be clear, Newton did not have a strong investment in any expectation that things happen instantaneously. His big concern was that it was action at a distance and there was nothing in between. That was just a little weird. He knew it worked, but he couldn't explain it in any way. But he was not deeply invested.
Put an example of that for me. So there's something in the distance, but nothing in between.
Let's say I turn off that light over there. It actually takes a fraction of a second for that light material, for that information to get to me that the light is no longer shining.
Right.
But
except for Muhammad Ali, who, you know what he said? He said, "I'm so fast, I could turn out the lights and be in bed before it's dark."
He also floated like a butterfly and stung like a bee.
Exactly.
That guy was pretty amazing. Yeah. So that speed at which that light and that dark travels to my eye is so fast that I, as a human being, could never detect it. But if I had a very sensitive camera that could really stop down time to billionths of a second or trillionths of a second at a time, you can actually see it getting darker as it moves forward.
To your eye.
To your
Light
eye.
moves 1 foot per nanosecond, per billionth of a second. So you just need billions, and you can catch.
Yeah. So
From the side, if you look at it from the side.
So you would literally see it. Right now there's a straight white line of light, and then you'd see it getting darker.
Well, there's also background light, right? Remember, our light is primarily illuminating.
If you have a laser and put chalk dust in there, and you see it, and then you do this,
that would work. That would be a great way to do that. Absolutely.
But people don't know what chalk dust is.
Go to a baseball game. You'll see
there you go.
Oh yeah, for the
right.
thing. Yeah.
So Newton really didn't get the sense or understand that there was a time lag. Right. Einstein.
Which is what gravitational waves is all about, right?
Right.
Well, they move at a speed.
Einstein showed that information in the universe, especially carried by light, right, and waves, has a speed limit. And then folks wondered.
And it's not just a good idea. It's the law. That's to say.
It's a great commercial.
Dad joke.
What is going on in your brain?
It's a dad joke. It's total dad joke.
I love the dad jokeness of that.
No,
it's really very good. So what happened is that Einstein showed that there was this reasonable sort of speed limit to the universe, and
Right.
the speed at which light travels in the vacuum. And then folks said, well, you know what? If that's the speed limit of light, maybe that's also the speed limit of these things, these other things, any information at all, you know. And so,
Like gravity.
yeah, so maybe gravity only travels at the speed of light. And that's important to know. When we see gravitational waves, we infer the existence of little tiny particles called gravitons that travel through space in order to have this wave happen. We still have never detected the existence of gravitons in the laboratory. We may never be able to unless we can get a particle accelerator the size of the solar system. But what we can do is to say, well, this proves that speed of light and speed of gravitational waves and so forth are so close to one another that there must be something there. So that in itself, I guess, is another discovery, right? By gravitational waves existing, you start putting strict upper limits on the mass of the graviton.
Just to be clear, before we knew anything about photons of light, light was described as waves. And then we learned that the wave particle,
Duality.
It can manifest as a particle, the photon, or as that you can detect, or as waves, which you can also detect as waves. By analogy to that, gravitational waves are granted a particle counterpart, the graviton,
which is a counterpart in a
to
way
the photon.
to a photon.
Correct.
Right.
And you need different mechanisms to detect it in that mode.
When we say particles collide to create virtual particles, do they really fist bump each other down at the Planck scale, occupying the same voxel at the same time? Or do they just get close enough and then, magic happens?
Great question. They get close enough. As an undergraduate, I learned some about a very technical, silly term called the impact parameter.
Love it.
That means that if you have two things coming toward each other, how close do they have to be before they impact each other, affect each
They
other?
don't have to touch
They
each other.
don't actually have to touch.
So if I did this to you, right? I'm not touching you. I'm not touching you.
He's not touching me. Stop
I'm
not
annoying
touching
you.
me.
I'm annoying you.
Let's go a layer deeper.
All right.
We did a whole episode of Cosmos on this. Because of electromagnetic forces, which hold your body together, when I go up to Charles and I touch him, if you actually analyze what's going on at the molecular and atomic level, I'm not actually touching him. There are forces in a field surrounding the particles, and it's the forces that are bumping off each other.
But
and this impact parameter exists when there are fields that surround the objects that are
Hang on a
coming near
second.
each other.
I can see my finger, my skin touching that surface.
So
So you're telling me that what I'm seeing
At a
isn't
very microscopic scale,
there's something
what's
between that plastic and
there
my
is
skin.
space between that plastic and your skin. But what happens is that the fields transfer energy. So your skin still feels as if it is physically touching something.
But
when in
that's something
fact-
coming from the bottle, and the bottle's coming from the skin.
Right.
There's-
So there is a tiny bit of space in between. And there is stuff passing between it.
otherwise your finger would just pass through the plastic.
So there's a space, like my
The plastic is
emotional, like my
preventing you.
emotional relationship with my wife. There's a sliver.
Yes.
We don't want to get into. So I love this. I love this. What
It is
Charles
cool.
says, because we don't hear that term much, but it's almost self-explanatory. It's the distance within which you can declare there was an interaction between the two
And
objects.
there's a way to measure that?
You can put it in the mathematical equations and say, okay, well, I have some force field in my finger. You have some force field in that plastic container. When they come together, how close do they have to be before I feel the force of those container particles pushing on my finger particles?
It's more precise than that. So you have two. I'm pulling this out of my 30-year memory.
30.
You can ask. Okay.
80.
So if two gravitational objects that come by, and one just gets pulled a little bit,
That's right.
you can say, all right, what does that mean? But you can define, just for conversational and mathematical purposes, the impact parameter is the distance within which its trajectory will be altered by more than 90 degrees.
It's pretty cool.
Yeah.
So
Okay.
that's why when we talk about, say, colliding galaxies, the stars in the galaxies actually never hit each other.
They never touch.
Almost never have direct collision.
Passes through.
But they go by each other. And
Yes.
as they go by, it's like a swarm of angry bees.
In fact.
And they affect each other.
And to the point where there can be an explosion.
To the effect where at times you will have an explosion. That's right.
So if I'm touching this,
Yeah.
is there a force that's strong enough or can be measured at which I can push those magnetic field or those fields apart and I'm actually touching it? Is it ever possible to eliminate that field that's between the thing, my finger and the pen, let's say?
It is almost never possible because there is a limit beyond which the math breaks down. You see, in the quantum structure of the universe.
By the way, I feel like I'm asking to use the car, and he's saying maybe, and my dad's saying, go ahead. No.
Sorry, let's back up for a minute.
Keep it under 30 miles an hour. You'll be all right.
Back up. Just story time real quick.
Okay.
Okay. I'll be reading from Merlin.
Can you have some milk? Warm milk? Hot cocoa? Can you get some hot cocoa, Alex?
Merlin's Tour of the Universe. Dear Merlin, is there a chance that another star will one day collide with the sun? Yes, but you should know that if there were just 4 snails randomly carousing across the continental United States.
Snails don't carouse.
Do they?
Snails cruise.
Yeah. What are they, alcoholics? drug,
hey, snail, how's it going?
Drug addled.
It's more likely for 2 of them to accidentally bump into each other than it is for another star and the sun
Seriously?
to collide.
Yeah.
Yes, and then my artist brother drew 2 snails colliding here.
One of which has a bandana and a gun. That's really weird. It's a carousing. That's a carousing.
So
there you go.
It's mostly empty space. So 2 galaxies colliding. The stars just pass through, but they definitely affect each other gravitationally.
So if this star is going by, there's enough energy there that it can cause each to explode.
Not necessarily. They'll cause each other to change their trajectories.
Yeah.
But once every 4 seconds or so in the whole observable universe, this is an estimate made a few years ago, there is actually a direct collision. Okay. This is most likely to happen in dense clusters of stars.
Very dense.
Okay, like globular
and
clusters.
near the center of the dense cluster.
Right. In the center of the star where, say, for example, in the space, which is normally, say, a few light years between me and us and Alpha Centauri, for example, there could be
The
a
nearest
million stars in that space. When the overdensities are 1,000,000 to 1 compared to, say, our solar neighborhood, you can actually have stars hitting one another, and they could actually explode. But the chances of even a collision causing an explosion are tiny because stars are mostly made out of gas. So imagine like a star going through another star. You're basically just having gas clouds smashing into gas clouds and go through. You need the cores.
But there are molecules within each gas cloud
That's right.
that could sort of collide,
They could,
no?
but then they don't cause a collision because they're so small, right? They're so low energy. But if you can get the core of a star, hit the core of a star, then
Now
you
you're
can
talking.
actually create a star happening. And you create collisions
Let's
and
make
explosions.
that happen. Come on.
At once every 4 seconds.
You guys are doing crazy
Somewhere
stuff
in the
basement.
Somewhere
huge
in the
universe.
huge observable
That's higher than I would have
universe.
guessed.
Nah,
Yeah.
I know you guys are doing crazy stuff in the basement of this place. Let's make that happen. Okay,
Sure.
I have more questions,
I'm not
but I don't want
authorized
to. I don't
to
want to.
divulge any more to you.
I don't have the clearance.
Have you ever wanted one of your questions on the universe answered? We all have questions about the universe. From black holes to quasars, quantum entanglement, wormholes. There is no end to the depths of cosmic curiosity. Well, the entry level of Patreon membership with StarTalk gets you just that. I think it starts at $5 a month. You have access to the question line that reaches our Cosmic Query programming. And not only that, we produce a special Cosmic Queries installment just for Patreon members.
If you weren't the director of the Hayden Planetarium, what do you think you would be doing? What?
Okay, but this had to be another universe. It wouldn't
All right.
happen in this universe.
Okay.
I'd be a songwriter for Broadway musicals.
Ooh!
So that's the entry level, and the perks ascend from there. There's a level, in fact, where we send you an autographed copy of one of my latest books. Right now, it's Starry Messenger, Cosmic Perspectives on Civilization. and it's signed with my fancy fountain pen with purple ink. So I invite you to just check the link below, and all of that money goes to our ability to experiment with new ways of bringing the universe down to Earth. So thank you for those who have already joined, and we welcome others to participate in this grand adventure of what it is to bring the universe down to Earth. As always, keep looking up. Paul, time for a couple more.
Oh, absolutely. Very good question here. This is from Morton Lurkjar. This is, I hope.
Who?
Don't make me say it a second time. It's greetings from Norway.
Sorry, Morton.
Okay.
Morton.
Oh, sorry, Morton.
Lurkjar.
Lurkjar. Yes.
I hope you can help clarify something for me. If our sun is a third generation star, how is it that we can observe earlier generation stars when looking back in time, since we are made up of the stardust from those earlier stars? Wouldn't their light have already passed by?
Perfect answer is the following. I am a third generation from my grandfather, but I can still see my great-grandfather if he's still alive.
Right.
The idea is that the generation in which you are created may have happened while those earlier generation stars are still alive.
Right.
So our sun is about 4.5 billion years old. But if a first generation star that created it was 4 billion years old, then the star that was before it was a few billion years old. But then there's a generation of stars that's 13 billion years old. We can still see them because they've still lived. They're alive still.
But that first generation star is always going to be mom's favorite. The
I'm
third
afraid so.
generation son,
Yeah.
Stop.
you leave the kid home alone, let him smoke cigarettes when he's 12.
Yep.
That third generation.
You
but
wipe
that
the
first,
binky on the pants
You know what
instead
I'm
of
saying?
sterilizing
You
it.
don't
Yeah.
care.
By the third kid?
Yeah, by the
You
third
take the kid to the track instead of taking him to the zoo.
You do.
I'm sorry, I'm really
This
putting
is
a lot of my
coming out.
personal,
This is coming out. in-
personal stuff coming out here.
Man,
Wait, Charles, I think you missed the point there.
I did.
I think.
Oh, no.
I think.
Sorry, Morton.
I knew that, but I didn't want to say it.
I think. Okay. The generation of stars that gave their lives to create the elements out of which we are made are not there anymore. You're not going to see your grandfather if you were made out of the flesh of your grandfather or your great-grandfather. They're not going to be there. They're dead because they gave their lives for you. What's going on here is as we look out in space, we look back in time and see the universe not as it is, but as it once was. So we can look far enough out into space to see the first generation stars do their thing. And beautiful. We can let's look 8 billion years ago. 8 billion years ago, those are stars manufacturing the elements, and they're about to die to make room for the second generation. And that light is only now just reaching us.
But those elements continue to exist like my great-great-grandfather's DNA exists in me.
Yes, but he ain't around.
He lives in you.
Thank you. Yeah,
Okay.
Oh,
yeah.
is that Lion King?
Yes.
Oh, yeah, good. Very good.
But he,
I recognize the first part of that, not the second part.
Sorry.
can we get a Mustafa?
We need a. Here we go, right here, right here. Okay.
Okay. No, we're mixing 2 points.
I know, but there's two different points.
Yes.
There's two different
One
points.
point is look back time, and
Yes.
the other is the age of things.
Okay.
Okay. When the first generation of stars formed,
Notice he said, when?
like Will Wheaton.
Yes.
Yes.
The whole episode of Family Guy on pronouncing.
Yeah. That was a good one.
Yeah, it
That was a good one. When you have a generation of stars form, you have some stars that die quickly, but then you have a bunch of stars that live longer. So those that died quickly contributed their information or their materials to the next generation.
Their elements, the elements that they made.
destroyed, right.
Meanwhile,
And those are the highest
that
mass
first
stars.
generation still
That's the-
exists. And then that generation goes, and then they form another generation. But those old stars from the first generation still exist.
The
And it's-
stars that did not give their lives for us
Right.
happen to live for 1 trillion years.
Minimum.
So, yes, at least. So they're all still around
Right.
in every galaxy, and that's not even about look back time. So, but some of them gave their lives for us.
That's right.
So the notion that we are second or third generation, generally that only matters because we have elements that earlier generations
Well, those
don't.
elements, isn't it, the third generation star, the sun, is composed of heavier elements like iron
Yes.
and oxygen.
Right.
Yes.
So that because they're heavier, they can exist longer, or
No.
They
It's
pass
just
on.
low mass stars live forever and high mass stars die.
Right.
And first generation high mass stars died for us.
So yeah. So the caveat is
They died for our sins. Yes.
the caveat is
fair.
that if there are not for well, okay,
You realize there's a logical fact in Christianity that if you don't sin, then Jesus died for no reason.
well, then I'd better get to going. I better
just
get
think
to
about it.
getting.
What have you been doing?
That's right. What are we doing?
The day just began.
Time's a wasted. What are we wasting time here? Come on. Show's over, everybody. We're going to go sin our asses off.
Just don't tell my wife. The first generation of stars, like the very, very first generation of stars, may have only formed short-lived stars. This is something that has been speculated. We're not 100%
It's like the
certain
0th
yet.
generation star.
Right. The ones that
I'm sorry, only formed short generation stars?
short-lived stars.
Short-lived.
Right. So it's possible that the original, the OG generation of stars is all gone.
Okay.
Okay. But certainly we can look back several generations and see that there are stars from previous generations that still exist
Going
today.
back to your sort of analogy of the great-grandfather, it's like, it's as if you can see those stars from previous generations that were, it's like your great-grandfather's still alive and you could go see him
Yeah,
somewhere, even
that's
though
right.
it's being...
Yeah, but he's not the one who gave you your elements. If you can still see them, they're not giving you the elements. If they're in your own galaxy, we have all generations of stars within our own galaxy. It has nothing to do with look back time.
Yeah, but the
Getting back to
elements in
Charles's
that
point.
star that I can see that's a previous generation to the sun.
It'll have fewer
Still-
heavy elements than we do.
Okay, but doesn't it share some of the same elements that the sun shares generationally?
It might. Yeah.
Yes, the sun has all of it plus the next generation's worth mixed into it.
Okay.
Yeah.
Great question. Great
Yeah,
point.
yeah, good one.
Okay.
Manaid Shandagai
Who?
from North Wales.
Who?
What?
Yeah.
Who? What's his name?
Manaid Shandagai from North Wales.
Wow.
Wow. Where'd you
Given
learn your Welsh? That's amazing.
Or Michael is his name.
Okay.
Given the relationship between speed and time and the relationship between speed and mass, is there also, therefore, a direct relationship between time and mass? In other words, if time were somehow to stop, would everything become infinitely massive? And would we be dragged by intense gravitational forces back into singularity?
Man. Man.
Well, I love that.
That's a drop the mic moment, everybody. I'm out.
The mic's on a mic
they
stand.
get some
so it's hard to
amazing,
drop.
Exactly.
amazingly thoughtful people in Wales that are
Yes,
asking
it's
questions.
incredible,
like this. That's
right?
incredible, man.
Yeah.
So do you interpret that the way I do? He's saying we know from relativity
Yeah.
that as you go faster, time slows down.
Yes.
And your
mass
mass increases.
Yes.
So instead of having it happen that way, let's figure out a way to slow down time.
Yep.
And would that then have associated with it an increase in everybody's mass?
That's right.
That's an
I
interesting
think that's
question.
a great question. I don't think that can happen. That's not how time works. Because what we're doing when we're measuring speed is how fast you are going through space, right? It's the distance you travel through space divided by the amount of time it took you to get there.
Is this question suggesting you could be dragged backwards in time somehow?
The suggestion is that you slow time down, right? I think that instead of going at 1 second per second, it becomes 0.9, 0.8,
to the
0.7,
point where
0.6.
something becomes
Right.
everything becomes singular.
Right. And I don't think that can work because the physics of time, which is still mysterious at certain fundamental levels, suggests that you can't really manipulate time that way, the way you manipulate space, or the way you manipulate your speed traveling through space.
That's a good point. And my
And so-
favorite thought about time is that we are prisoners of the present, forever transitioning between our inaccessible past and our unknowable future.
You just gave me a headache. I don't even know what you're talking
You know,
about.
I know you'd like that, but I prefer
What,
mass.
you gonna mess with that?
No, but I'm going to provide an alternative from that incredible, deep
Lofty.
document,
Lofty.
Kung Fu Panda,
Kung Fu Panda
from
moment.
Master Oogway.
Okay.
Right? The past is history. The future is a mystery. All we have today is a gift, and that is why it's called the present.
That was from Kung Fu Panda.
Yes, it was.
Okay.
It ain't over till it's over.
Yogi.
That has a time
the
aspect to it. If you
most-
think about it,
Most profound
don't
of
look
all.
down your nose at that.
That only works in baseball.
No, if you think about
If
it on
it's
a
the
deeper
Super
level.
Bowl, if you're in the Super Bowl and one team is down by
How about it's
21
getting,
points,
How about it's getting
and
late
it's
early?
3 minutes late,
Don't you love it's
the
getting
game
later?
is over. Okay, so
It's not over. You still have to put the 2-minute warnings commercials in.
Exactly. Right. You got to sell some soap,
but the
buddy.
full significance of that comment can only exist in baseball where there is no clock. Except now there is with the pitcher. I think that's all the time we have.
Yeah, it's called.
No,
it's,
really?
So, Charles, you finished a
Yeah.
book recently.
Yes.
I loved it. The quantum something.
The handy quantum physics answer book.
to have the
Thank you.
word handy and quantum in the same title. That's badass. Right?
The goal is to help everyone understand.
which we need, like this is basic levels, basic explanations of complex things.
You know,
yeah.
quantum feels scary. It feels unknown, but actually we interact with it every day. And so think of it as a handbook. Don't think of it as a textbook.
Okay.
Yeah.
Good. Yeah. Good.
Nice reference, guy.
And Paul, where can we find you next?
Permission to Speak, my Broadway show directed by Frank Oz.
Wow.
The original Yoda and all of that, and the great director. We are taking it on a national tour. We're going to be in Florida, in Orlando, Florida, and in Fort Lauderdale at the Broward Center for the Performing Arts. Dr. Phillips Center in Orlando. We're going to be in Rhode Island.
These
my
are all the
home
good
state.
places.
Yeah.
This is a real
Your
theater.
show.
Yeah,
we
Very
must.
nice.
We got a set designed by the set designer for The Late Show, and we have animation.
Oh, because you also moonlight.
I work at the Late Show with Stephen
with
Colbert,
Stephen
and
Colbert.
through that show,
You
the
warm up
show-
the
warm up and I'm going to be making another appearance. I'm going to be making another stand-up appearance on the show after the first of the year too.
Fantastic.
And so we got a really cool
so you don't
set.
only warm with the audience. Occasionally he'll bring you on for the broadcast.
Oh yeah.
Yeah,
I've done
cool.
a bunch of appearances on
That's
the show or do
fantastic.
sketches and
That's
things.
My few
wonderful.
times been on, you came and said hi to me. I love
Yeah,
that. Thank
every
you.
time. Yeah, absolutely. And he's like, "Don't make eye contact with me." I'm like, "Okay." All right. And we got really cool animation in the set. It's J.J. Settlemeyer who did Beavis and
Wow.
Butthead and all the SNL TV funhouse. We had created this. It's a multimedia show with a set with this really cool.
That's
we're gonna look for you.
fantastic.
So it's really cool.
That's
so yeah, so
fantastic.
people can go to paulmecurio.com, get tickets, come out, support the show would be great.
We
Thank
got
you
it.
so
Or
much.
Permission to Speak is the name of it. So
Permission to
this has
speak.
been really great to be on with
Hey,
you.
what
As
fun.
I read some of your
Thank you,
work, and it's
Paul.
really great.
Thank you.
Him, but
He
you,
never shook my hand. He never shook my hand.
come on. I love you, buddy. I love you.
All right, that's all the time we have. This has been a StarTalk Cosmic Queries grab bag. That was definitely some bag grabbing right there. All right, until next time, Neil deGrasse Tyson bidding you all to keep looking up.
Thank you.